Okay, good afternoon all. Thank you for joining today's webinar and taking the time out of your day or your lunch breaks. We've got a lot of packed a lot of insightful and informative content around industrial AI and IoT in practice for today's session. We're going to start promptly as we do have a lot. We've got 3 presentations and a little bit of Q&A to get through. So we'll just allow some latecomers to join us and when they do. Speaking of the presenters, we'll be kicking off with Rory from Smartia, who will talk around 15 minutes around Smart Robotics. Moving on to Jonathan Butt from the National Composite Centre, and finally ending with Jonathan P. Martinez from Airedale, and then we built in around 10+ minutes for Q&A. Not much in terms of housekeeping, so I'm sure you're all at home and familiar with where your own bathrooms and fire exits are, in case any of those eventualities crop up. But just in terms of a smooth running for this particular webinar, if you could remain on mute throughout, just so there's no feedback or distractions for any of our attendees or presenters, and also if you could use the chat feature at the bottom of the screen to enter any questions that you may have, and those will be taken on at the end of the session. Don't worry about leaving it until the end to submit those questions. Just as and when they come to you, you can submit those in the chat box. Just a little bit of background around Smartia. So Smartia are an AI and industrial intelligence startup. We've been trading for roughly 3 years now, and the essence of what we do is providing scalable AI solutions to connect and transform industrial data into actionable insights. A big part of how we do that is our core technology, which is MAIO, our industrial intelligence software platform. This allows companies to connect all manner of industrial assets, extract data, collate all that data, and then apply machine learning and AI techniques and principles to that data to be able to deploy smart applications. We have a world-leading team of software engineers and data scientists from a diverse range of industries, from your big tech companies like Google, as well as manufacturers and engineering companies such as Airbus from Rolls-Royce, as well as in finance with Morgan Stanley. And we're headquartered in the beautiful sunlit city of Bristol. Moving on to a brief introduction of our presenters, who I'm sure will introduce themselves as and when their presentations come up. So we got Rory Gold from Smartia, who's one of our data scientists, and then Jonathan Butt from the National Composite Centre, who is Deputy Chief Engineer at the Digital Business Unit within National Composite Centre, and then finally Jonathan P. Martinez, who's Commercial Controls Manager at Airedale. So without further ado, I'll stop sharing my screen and allow Rory, our data scientist from Smartia, to get us kicked off.
Yep, perfect. I'll just share my screen quickly. Okay, perfect. Hi guys, can you all see my screen okay? And can everyone hear me all right as well?
Yes, perfect.
Okay, fantastic. So yeah, my name's Rory Gold. I'm a data scientist at Smartia. So that in kind of the day-to-day, that includes taking in data sets from our clients, performing analysis on those, and then developing machine learning models which can help them to solve problems and learn more about their industrial assets. So I'd like to take you through our Smart Robotics project step by step and show you the benefits of combining AI and robotics. And yeah, any questions, please do just put them in the chat section, and we'll get to those in the Q&A. Okay, so I'll give you a quick intro into the. Sorry, can you? Are you guys able? Sorry, I just want to check. Are you able to see the WebEx images of yourselves, or is that blocked from you guys?
That's blotted. I can't see it. I'm just seeing your slides.
Okay, excellent. Sorry, I just wanted to double check that wasn't showing up, but that's fine. Okay, so so a quick intro to the project. So as we all know, the COVID pandemic has changed how we work. It's changed people's perceptions of work. It's changed how companies operate, and it's also shone a light on how digital technology can help us. So an example of the response to COVID was an Innovate UK call for projects which would explore technologies like robotics and artificial intelligence, and how they can be used to improve resilience in affected industries. So the Smart Robotics project was our answer to this, with a real focus on the hard-hit retail sector. And before we go into that in detail, I just want to give a bit of context around robotics in industry. So just there you go. So as we know, robots have been used in industry for decades, and we're really quite used to seeing images of robot arms in all sorts of places, from car factories to high-tech clean rooms. And robots can be really beneficial. They remove humans from low-value, repetitive, and often and possibly dangerous tasks as well. And they can also help augment human workers. This can help them to achieve their tasks quicker, and also allow them to focus on more valuable tasks. And the way this normally works in industry is for a company to bring automation into their business, the conventional way is for them to speak to an integrator who would design and install a turnkey solution for their use case. And these robots would be programmed to move over fixed toolpaths and carry out set tasks at certain locations at set times. And the result is a highly repeatable and reliable system which will carry out this well-defined work. But once the system is integrated, it doesn't really change. And historically, for a lot of mass production tasks, this has been fine. But with the current trend towards offering things like customer choice and customer selection of items, and also customation in the design products, in designed products, this is not sufficient. And the problem here that we're trying to address is, what if your use case changes? So, for example, say if we have a robot picking up parts, what if our business needs change and we need to add a different type of part for the robot arm to pick up? Or what if we need to alter the configuration of the working area for the robot? At present, the integrator from before will, might need to come back and reconfigure the system so that it's suitable for the new case, for the new use case. But this is going to add extra costs, and also it could take quite some time. And that that lack of flexibility and not sort of a business's loss and ability to react quickly to changes is an issue that needs to be addressed. So the Smart Robotics project, was really an opportunity to show how robotics and AI can be brought together to not only achieve a given use case, but also to provide that much needed flexibility to the process. Removing that barriers for that barrier for companies wanting to invest in automation. And our use case for the project is retail themed, but the ideas are applicable across many industries. And the use case the use case that we selected was robotic order fulfillment. So the idea is that a robotic arm could pick items like the robotic arm shown in the picture on the left. Can select items according to customer orders from the picking area, which is sort of that kind of dark slate-colored surface in that image. and deposit them in a packing area for subsequent shipment. And this is a really common operation, not just in retail, but also in many industries, from manufacturing to logistics. And so our industrial intelligence platform, MAIO, is really ideally placed to be the foundation of a project like this. It provides machine connectivity, machine learning capability, and also a user interface. And the platform can be connected to all sorts of physical devices, whilst also hosting many different data processing pipelines, and providing that flexible user interface. And because of that, the system that we have built can be given new capabilities with a simple software update. For example, if we wanted to add new product lines in our demo shop, we could update the vision processing model. And if we wanted to get extra performance from the robot arm itself, we could update the software to identify more efficient motion paths based on live robot data. And now I'll just give you a run through of the architecture of our demonstrator and how it all fits together. So first we have our physical assets, which you can see here. So we have a robot arm with a controller, and also a camera. The robotic arm, which you could see in the previous slide, is an EVA collaborative robot arm from Automata, and it's a cost-effective arm with the added bonus of being able to work in really close proximity to humans. And this robot was fitted with an electronic gripper. And there's also this camera, which is an FLIR camera, and it acts as the robot arm's eyes. It acquires images of that picking area, which are then processed. So we've got these two devices, and then we need to connect them to the software, to the MAIO platform. And these are connected using gateways. And what these gateways do is they acquire data. So image data in the case of the camera, and positional data in the case of the robot. But in addition to acquiring that positional data from the robot controller, the robot gateway can also send commands the other way. It can transfer data from MAIO back to the robot controller itself, so that it knows where to go when it needs to pick up an item. And we call this layer the MAIO edge. So it's the interface between our devices, which in this case the camera and the robot controller, but really could be any kind of industrial asset, and our platform, MAIO. So what happens is MAIO takes the data from the camera, so images of the picking area and the objects which are on it. And then it processes this image using machine learning. And in our case, machine learning is used to both identify all of the different items in the picking area, and then also specify their exact locations to the platform. So it uses this information to then plan out a trajectory or motion path which will complete any customer order assigned to it. So MAIO then sends this motion plan back to the robot gateway, which then communicates it to the robot controller, which allows the robot arm to execute the object selection. And then finally, any customer orders are inputted into MAIO via the storefront app, which we can see here just in the shop application. So MAIO acts as our orchestrator for all of this. It connects our real world devices. It processes the data, and also provides sorry, I think someone might be off mute.
I put them on mute now, so it should be fine.
Yep, sure, no worries. And it also provides a user interface, so the user can interact with the system. So I'm quickly going to take you now through the machine learning side of things. And just I'll give you a bit of context to start off with. So using machine learning and AI in robotics is very much an emerging and growing field. It really has the potential to transform what robots can do, and it's key to increase the flexibility of automation systems, and hopefully encourage cautious companies to invest in these technologies. As mentioned in the previous slide, here we're using machine learning to process images of the picking area in order to locate all of the different stock items. So this is both a classification and a localization problem. Many existing vision solutions tend to use conventional image processing techniques, and these can be really sensitive to things like lighting and the placement of cameras, which can impact the detection reliability. But machine learning can provide a more flexible and a more robust process. So the model and the approach which was used is something called instant segmentation. And what instant segmentation does is it goes that extra step beyond object detection. So here on the left, I've got an example of object detection where you can see that the images of the dogs and the cat have been broken down into, you know, sort of here is where each dog is within the image. So there you can see that the object, so that, you know, the dog or the cat has been identified, but its location has also been placed within a bounding box, which isn't really good enough for what we need to do. We need sort of really reliable and accurate localization of each object within the image, and that's what instant segmentation allows us to do. It identifies the item reliably, and also it tells you which pixels in the image correspond to which object. And this is really powerful because we can then use that information to direct the robotic arm. And just a little bit about sort of the data and the training side of things. So the images you can see here are images taken from the FLIR camera attached to the robotic arm. And the model was first trained on images of the small colored blocks, so as you can see on the left, and then expanded to include more exotic objects, such as your sherbet lemon and the battery as well on the right there. And these images were taken in a range of different lighting conditions, to which increases the robustness of the model. In this use case, when I say training, I'm referring to the machine learning model, learning what each object looks like and then how to locate it within the images provided. And to perform that training, we used a technique called transfer learning, and this is a really powerful technique. Transfer learning works by, you start off and you take a model that has already been trained on thousands of different images, and then you repurpose and you fine tune it to your specific use case. And there are a number of benefits to this. You know, it greatly reduces the number of images for each object you need for effective training. It reduces the amount of time taken to train the instant segmentation model, because you're not starting from scratch, which is, you know, really important when you want a tight turnaround. And also it makes it possible to add more items for your robot arm to select without the need to reconfigure the entire process. And it really gives that important flexibility. And to do that, you just have to add more images of the item which you want to train, which can be fairly simple to do. And I'll just show you now the model results. And this is a screenshot, so I apologize for the roughness of the image, but you can hopefully you can sort of see, get the idea. So on the left is sort of an a standard image which is inputted into the model. So you've got your trained model and you're giving it this image. And this is an image which the model hasn't seen before. But you can see that it's able to accurately identify and locate each object on the selection surface with high levels of confidence. And then the locations of each object are then used by MAIO to create that trajectory, which is passed on to the robot controller as a motion panel. As a motion plan for the robot to then select each item. So I'm now going to quickly show you all of this working end to end. So we've just got a short video demonstrating how our system works to fulfill those orders as they come in. So just give me a sec and I'll get this set up. So I'll just put the sound on, bump up the quality. Okay, and now just to finish off, so in this project we've shown how the MAIO platform can be used to achieve digital transformation of a sort of usually manual process. MAIO allows us to tie together sort of a number of standard off-the-shelf devices, a robot arm and a camera system in this case, and provide data processing with machine learning, which helps to create a flexible and automated system, which isn't limited by its current process. We can easily see how just by updating the machine learning model, we're able to give the robot new items to pick and new behaviors, which can be added as business needs change. And this software-led approach really means that going back to sort of conventional integrators could be minimized. And it really helps to put control back in the hands of the end users and allows them to explore the potential of robotics and automation. So that's everything from me. So I'll just stop sharing my screen. And we can, get back to the webinar.